Good evening and welcome to another live book reading from Tilly Publishing UK, me, and Wine and a Book, and evenings of Indie Author Week UK, celebrating the fact that independent authors have variety and I want to say talent, but that sounds wrong when I say it as an indie author. Anyway, the whole idea of Indie Author Week is to showcase independent authors and the fact that a bit is not where you shouldn't really be what's going on. Anyway, tonight I'm reading from Simon's book, my book, our shared book, The Lichens of Jersey, which took 10 years to write. We published it in 2015, so one or two of the things that I'm going to read aren't fully up to date. And so I'm going to attempt to give a sort of nudge that what has changed in the interim. It took 10 years of intense field work, and we were given the go-ahead to produce a full colour lichen flora because there was a very significant Jersey lichenologist called Charles Dubois Lavoisier, and we were looking for his history, and it turned out that a huge number of lichens named for science were found by him both in Jersey and in Connemara, where he was a tutor. Not that that's the bit I'm going to read from, but it's interesting. So the whole idea of what is a lichen, what Simon learned about lichens from the most wonderful Dr. Francis Rose, and they'd met when they were working together in the New Forest on a committee to do with the New Forest, and Francis invited him out to look at lichens in the New Forest. And at that point, coming from Leicester, he'd been in Leicester. I'm not sure where he born in Kent. So the lichens he knew were in Charnwood Forest. Not a lot of them because it was the era of acid rain. And so when they went out into the woods and Simon first saw the lichens on the trees of the New Forest, he said, "I didn't know lichens grew on trees." So even when you're a fairly experienced naturalist, it doesn't necessarily mean that you know what it is that you're seeing. So this afternoon, I photographed an oak tree nearby. Anyway, there are branches there that should be sideways on, and they show that the branches of oak trees have lichens on. And the trunk, on the other hand, was a bit naked. It did have ivy growing on it for a good number of years, but it's a couple of years now since the ivy was stripped off. Oak trunks tend to be less good for lichens than the branches anyway. So lichenologists prowl around under trees as well as looking very funny as they look at trees. And so I prowled around, and I think this is what's known as Ivernia prunastri, and that had fallen off one of the branches of the oak tree, and it's because it's dry, it doesn't bend, it's quite crispy. But if I was to spray it with fresh water, then it would actually go soft again. So, and to look at them most lichenologists use hand lenses, the bigger one, the bigger glass, because it's really hard to use. There are some wonderful ones that have lights now, which are great. So, right, and the reading. This is going to be a bit of a tongue twister. So, apologies if my tongue trips over. There's an awful lot of fancy pants words, but it's lichens aren't straightforward. They're wonderful. They're in their complexity is their wonder. In their beauty is their wonder. It's actually not possible to get to the bottom, top, middle, whatever of lichenology, which is a fantastic challenge. Right. An introduction to lichens. A lichen is an organism that consists of a fungus growing with an alga in a relationship known as symbiosis. In lichen associations, the organism is named for the fungal partner. This fungal partner is known as the microbiont. The algal partner involved in a lichen association comes from relatively few species, but these belong to a wide spectrum of algal groups. Although the phytobiont or algal partner has received scant attention until recently, there are probably less than 30 algal genera worldwide that form lichen associations. Algae involved in lichen associations belong to the green algae or chlorophyta and to the blue-green algae or cyanobacteria. That's no longer called algae, that's now called bacteria. So it's a triple rather than a dual, and there might even be some yeasts kicking around as well. In lichen identification, the nature of the phytobiont can be very important. Blue-green algal lichens are usually comparatively easy to separate from green algal lichens by their rather jelly-like appearance, but some form beautiful bluish through dark reddish-brown to grey-black lichens. Green algae form lichens exhibit a whole range of colours, including green, light blue, brown or white. Some green algal lichens can even be bright orange or yellow due to the presence of orange pigments. The orange-coloured alga genus Trentipolia also forms a large number of lichens, many of which are a bright orange or yellow colour. In spite of its orange or orange-brown colour, Trentipolia species belong to the green algae. Many lichens containing Trentipolia are not yellow or orange, but by scratching them, they reveal a yellow layer beneath the surface, which is often diagnostic. This characteristic yellow colour shows that the lichen belongs to the Trentipolia group of lichens. This state of affairs presents one of the many fascinating problems that lichens offer their devotees. There are a number of fungi that form lichen associations with more than one alga, and depending on the algal partner involved, such lichens can exhibit strikingly different appearances. For instance, the lichen Sticta canariensis forms an association with a green as well as a blue-green alga. Until fairly recently, the lichen Sticta dufourii, the blue-green form of Sticta canariensis, was considered a distinct species. However, plants of Sticta dufourii with the green lobes of Sticta canariensis growing out of them have been found. It was then realised that Sticta dufourii was simply the blue-green morph of Sticta canariensis. The problem arose as to how it could possibly be referred to scientifically, i.e. taxonomically. How can it be named? The genetic makeup of the fungal partner when one morph is growing out of the other is identical, and since it is the microbiont of a lichen that gives it its scientific name, there was no method available for naming the two different morphs. Today, then, Sticta canariensis, the traditional name for the green morph, is referred to as Sticta canariensis green morph, while Sticta dufourii, the traditional name for the blue-green morph, is referred to as Sticta canariensis blue-green morph. However, the two morphs look very different indeed. Similar dimorphic states exist in the genus Pultidra, amongst others, and are frequent in the tropics. So it then goes on talking about something called the Schwendener debate, but I'm skipping that bit because it's complicated. Not that this is anything other than complicated. So, the British Lichen Society has for then 50 years, now 60 years, been the major organisation that studies lichens in Britain, including the Channel Islands, the Isle of Man and the Irish Republic. Approximately half its members are from overseas, and the Society has developed an international reputation and tradition. In theory, the organisms that the Society studies should be straightforward, but in practice this is not the case. As put forward by Schwendener in the mid-19th century, a lichen is a fungus that lives in symbiotic association with an alga. Unfortunately, things are not that simple. In fact, one definition of a lichen as regards the Society has been that a lichen is a fungus that forms associations with an alga, as well as any other non-lichenized fungus that the Society may decide to study. Some fungal genera, such as Orthonia and Arthropyrenia, contain lichenized and facultatively lichenized, as well as non-lichenized fungi, and the Society studies all species within each genus. There are several genera, such as Stenocybe, Niacea, Sarcopyrenia, that contain no lichenized fungi, and yet by tradition they are studied and appear in the flora published by the Society, the Lichens of Great Britain and Ireland. This has now been updated, or is being updated in parts, and there are updates available on the British Lichen Society website, which I need to put in the description, really, don't I? In the case of Stenocybe septata, a few algal cells have been observed within its tissues, and this has also caused confusion. There are fungi that grow in association with or on other lichens with varying degrees of parasitism. These are known as lichenicolous fungi or parasymbionts. The low degree with which they are often studied by members of the Society seems a little irrational. That has changed a bit because there's a book by Frank Dobson that was updated with some of the lichenicolous fungi in the end. So there's a lot more work that's been done since then. Some literature is available on this fascinating group, and a proportion appear in the checklist of lichens of Great Britain and Ireland. Science is always growing, always growing. While many lichenicolous fungi grow harmlessly within the thallus of their host, taking advantage of its lichen association, an infection by others, such as the bright pink Marchangiomyces corallinus, is parthenogenic and can be rapidly lethal to the lichen. They're very pretty. Genera such as Orthonia contain both lichenized and lichenicolous fungi. Lichenicolous fungi inhabit different parts of the host lichen and may be restricted to the fertile part, known as the ascocarp, or found only on non-fertile parts of the thallus. The presence of the lichenicolous fungus Orthonia varians, a relatively common species on Lichenoria rupicola in Jersey, is easily recognized as it turns the surface of the fruit black. Some lichenicolous fungi modify the appearance of the host in specific ways by, for example, suppressing the normal growth of Soredia or Isidia, which are replicating bits. Some lichens, such as Diploschistes muscorum, require the thallus of a species of Cladonia, most frequently Cladonia postulum, which they first attack, then kill, and eventually become completely independent of. The vast majority of lichens belong to the Ascomycetes fungi. However, there are a few that are Basidiomycetes. Not all lichens are fertile with spore-producing bodies. Some spores are even asexual and produced vegetatively and are then known as canidia and are produced in organs known as pycnidia. That's the tongue twister. However, the ascomycete lichens, when fertile, produce round ascocarps and pyrenocarps, or worm-shaped litteli that produce ascospores. A few, particularly in the fungal genus Lichenomphalia, are basidiomycetes, and when fertile, produce toadstools, little ones. In one or two British species, the phycobiont belongs to the hyphomycetes. There is a rather rare species from Ireland and the southwest, not yet found in the Channel Islands. Because it is such a strange entity and was first found in Ireland, it has been given the delightful name Blania hibernica. There is the strange case of Normandina pulchella. It was always considered in the past that it had never appeared fertile and that its correct classification remained a mystery. Its similarity and the shape of its thallus to lichens in the basidiomycete group seem to underline this. However, the new lichens of Great Britain and Ireland accepts the consensus of recent opinion that the black pyrenocarps on its surface are not lichenicolous, but are in fact a lichen in its fertile state. It is somewhat sad that the genus into which the pyrenocarps were put when it was thought to be a parasitic lichenicolous fungus was Laudelindsia, honouring a 19th century lichenologist, now lost. From time to time, as with any group of organisms, the question, what is the point of lichen, is asked. Lichens can be very useful in many ways. For example, the lichen Roxella babingtonii is abundant on many trees and shrubs in the Galapagos Islands. From it, a fine purple dye can be obtained, and it was partly the commercial implications of the source of this dye that caused Ecuador to annex the Galapagos Islands in 1832, rather than any potential for ecotourism. From other members of the genus Roxella, the dye litmus can be manufactured, but is so useful in distinguishing between acid and alkaline substances. The frequent occurrence of Roxella futiformis on the coast of Jersey is interesting. So far, we have been unable to find evidence of its use in the Jersey woolen industry, but it is hard to believe that such a natural purple dye was wholly ignored prior to the invention of easier techniques in the 19th century, particularly given it was one of the early lichens that Lavoisier was mooching around for. Lichens contain lichen acids, a series of complex chemicals which change colour with chemicals such as potassium hydroxide and bleach. Some of these colours are fast, are beautiful, and have been used traditionally as fabric dyes. These reactions are also very useful in lichen identification. Some of the acids cause the lichen to glow in ultraviolet light, and this is also important in identification. Eastern people, such as the Japanese, eat lichens, although there is little tradition of their culinary use in other parts of the world, although celebrity chefs seem to have decided that they like it. Some lichen acids are poisonous. A very common lichen, Ivernia prunastri, this little bubba, I think, is used especially in France in the manufacture of expensive perfume. When crushed, it does have quite an exotic aroma. In fact, it is so sought after in France that it is harvested in commercial quantities that threaten it, even although it is a common species. The lichen Cladonia stellaris is a species from Northern Europe. It is not present in the British Isles except where it is found on sale in hobby shops in city centres. It has been extensively used in the construction of architects' models as miniature trees and by model railway enthusiasts, and is threatened in the wild by these activities still, although a lot of architectural models are now done by AutoCAD. One of the most important uses of lichens is in their sensitivity to environmental pollutants. It's also one of the most famous, and the exacting conditions that many need in which to grow and survive. William Nylander had noticed the effects in Paris in the 19th century. He was a Finn, but it was in the 1960s that alarm bells began to ring. Lichens were disappearing everywhere, and the link between this and high levels of sulfur dioxide in the atmosphere from industrial pollution was made. Francis Rose and David Hawksworth researched lichen sensitivity to acid rain and produced a table which went from no lichens at all through relatively tolerant species to sulfur dioxide such as Lecanora kinesioides and Hypergymnea physodes, through to the most sensitive such as Usnea articulata and Teleschistes flavicans. Studies of distribution using these indicators were put in place, and the degree of sulfur dioxide pollution in the British Isles was mapped. Acid rain and sulfur dioxide pollution became an issue taken very seriously by the general public. It was found that there were virtually no lichens either side of the main A1 road from London to Newcastle. As a direct result, a politically backed campaign to improve air quality resulted. Today in the British Isles, acid rain caused by sulfur dioxide is virtually a thing of the past. Sulfur dioxide pollution has not altogether disappeared, but is more localized. For instance, shipping exhaust does produce significant quantities of sulfur dioxide. Sulfur dioxide pollution has largely been replaced by a problem which is equally insidious and, unlike acid rain, is currently of major concern in the Channel Islands. Today, the pendulum of atmospheric pollution has swung from acid towards alkaline throughout the British Isles. Although there are acidic nitrogen compounds that are released into the atmosphere, the majority are alkaline. The bright orange lichens belonging to the genus Xanthoria, where are we? Xanthoria. It doesn't show up terribly well, but the top one really doesn't show up terribly well. Especially where they grow on the twigs of trees with an acid bark, such as oak or alder, indicate nutrient enrichment or eutrophication caused by nitrogen compounds in the atmosphere. In the last 20 years or so, the lichen flora in central London has moved from highly impoverished due to industrial pollution to an enormous improvement in the flora that indicates less acid conditions. However, because of enrichment by nitrogen-based chemicals, the flora is becoming impoverished again due to lichen intolerance of eutrophication, and it's different species that are responding. The situation in the Channel Islands is not good, but not as alarming as that in London. A major cause of this enrichment of the atmosphere is due to intensive agricultural practices, and especially the use of inorganic fertilisers that can drift in the atmosphere. The use of catalytic converters on car exhausts releases quantities of ammonia into the atmosphere. In Jersey, as in other parts of the British Isles, this eutrophication has caused enrichment in heathland, causing more vigorous higher plants such as coarse grasses and bracken to increase. This has been to the detriment of lower plants in particular, as they require small gaps in the vegetation to become established and to flourish. Perhaps the greatest menace in Jersey is the increase in bracken, bramble and gorse, which is so marked in former heathland areas such as parts of Portelaye Common. So it's going to be interesting to see what difference the higher proportion of electric cars is going to make. So see what lichens report on that one. I do have an idea to do a book on the storytelling that lichens can do. So Xanthoria parietina has a particularly descriptive behaviour because it likes to grow where birds perch or dogs pee. So yeah, there's definitely a book to be done there, but there's got a few more to do before then. Anyway, that's 25 minutes. Yes, sorry, but there's a lot in it, in that section, and it's a lovely, complicated but lovely topic, and they're very, very beautiful. So thank you very much for joining me. I forgot to toast. So wishing you all the very best and lots of health, and thank you and good night.